Alright, so section 3.3 kind of takes this whole idea of systems, and now we're going to look at what it's going to mean when we start talking about systems of inequalities, linear inequalities. Last section we spent at least a couple days, I guess maybe at least a few days, on systems of equations. So now we're going to kind of build this into and take it to the next level and talk about systems of inequalities. So first, like I was just kind of referring to, recall any solution to a system of linear equations is an ordered pair that solves both equations. You can also have systems of inequalities. I was just saying that. These systems can include linear inequalities as well as absolute value inequalities. So yeah, that's some daunting, sort of some ominous like foreshadowing there of our lesson today. Absolute value inequalities. But just like linear systems, all capital letters, just like linear systems, a solution to a system of inequalities is any ordered pair that makes both inequalities true. And if there are solutions, we can only show them all by graphing. And I guess you're going to kind of see it for yourself momentarily here. And perhaps you can remember doing this in Algebra 1 or whatever. But if it hasn't hit you already, by thinking about this or what I just read here and wrote and what we just kind of looked at here, you're not going to be in a situation where you have two lines that are just going to be crossing at one and only one point. Do you remember, like, all the solutions to a linear inequality or an absolute value inequality? Like, not only do you have like the graph of your line or the graph of your v, but because it's an inequality, now you have all of the shading that you need to have on your graph to represent all the solutions that are either like above your line or v or below your line. But we'll see that here, okay? So here's an example. Here's our system of two linear inequalities. And all we're going to do, and okay, like if you want to boil this down as simple as possible, here it is. The approach is just to graph both of these on the same plane. So, I mean, like I always say, if you know how to graph one of these at a time, you sure as heck can graph two at a time. That's all you're really doing, And there's going to be like a tiny plot twist on top of that. But anyway, so this blue one, y is less than or equal to negative 3/2 x plus 5. This one's good to go. Okay? Remember, to graph this, I'm just going to graph this as a line. But that line might end up being dashed. And you also have to shade above or below. But as far as like graphing the line, this is already in mx plus b form. So I have this line here ready to go. But this other one, x minus 2y is less than 6, first you have to put this in slope-intercept form, so to speak. And did I just recopy this? No. So the first thing I'm doing is I'm subtracting x away from the left side and over to the other side. So I'm subtracting x from both sides to get to here. Okay, just kind of moving that x to the other side. So now it's negative x plus 6 over here. We still have a negative 2y. What's the next thing we would do before we can identify m and b, slope and y-intercept? We got to finish getting y by itself. So we divide both sides by negative 2. And remember, make a note of this if you need to, Remember the thing with inequalities. If you divide both sides by a negative number, this symbol gets flipped to a greater than. So here it was like negative 1x divided by negative 2. Well, overall that's a positive 1/2. Negative divided by negative is a positive. And then positive 6 divided by negative 2 is a negative 3. So here is like my final version of this inequality. So now I know that my b value is negative 3, my y-intercept, and my slope is 1/2. So that leads to this line. And, well, spoiler alert, why did I make it dashed? You got to remember with these linear inequalities, sometimes your line is dashed, okay? And because the symbol was strictly greater than and not greater than or equal to. Like this one, this blue line is going to be solid because it wasn't just less than, it was less than or equal to. All right? Now we also need shading. So since this was, and you also here you look at the symbol as a shortcut. Remember the whole test point thing? We could test out 0, 0, but we have a shortcut. The symbol is greater than, so we're going to shade above. Now shade very lightly. Shade as lightly as you can. Okay, you'll see why in a minute, or maybe you remember why. But shade very, very lightly, okay? Now so we've graphed this one. Now we're going to graph the other one. And like I said, I already had this good to go, because we know that the b value is 5. So 1, 2, 3, 4, 5, right here. Oops, darn it anyways. This point right here, and then the slope is negative 3 over 2, so it goes down 3 over 2, down 3 over 2, down 3 over 2, right? And it's a solid line, like we've already said. And as far as the shading goes, it's a less than or equal to, so, we're going to shade below that blue line. Again, lightly. As lightly as you pretty much can, because remember the whole story here. Your final answer, your final giant set of solutions are going to be all the ordered pairs that solve both of the linear inequalities at the same time. Remember, everything in red or pink is what solves this inequality, I guess nothing on that dashed line because it's dashed, but everything in this pink shading solves this one. And everything in the blue shading, and I guess also right on this solid blue line, would be all the ordered pairs that solves this one. But the final answer, all the solutions to the system, like these two inequalities together, would be, obviously, again, everything that solves both of them. So, in other words, what we're looking at here as our final answer is everything in the double shading. Wherever you shaded twice, that's going to be your final answer. So you're going to darken in the quadrant, where you were doing double shading, where the graphs overlapped. And so that would be our final answer. So in other words, a point like 4, 3, oopsie daisy, 4, 3, 1, 2, 3, 4, 1, 2, 3. So right there, this point would solve this, but not this one. And so, 4, 3 would not be a solution to the whole system. Likewise, a point like 2, -4, right there, this ordered pair only solves this one, doesn't solve this one, so 2, -4 is an example of one, that is not a solution to the system. But anything in the final shading, like -2, 1, this is a pretty good example of an ordered pair that solves both and therefore is a solution to the whole system. Okay? Let's just do some more examples. I don't think, until we get into like absolute value, I don't think there's going to be any major plot twists. So you might want to try these on your own. You can totally feel free, at least for these two here, to pause the video and try both of these on your own, because I don't think there's anything else I need to actually teach you for the first time. But I'm going to start going over these in 3, 2, 1. Alright, so you've been warned. Alright, so it looks like both of these are good to go to graph. I already know here that this is an mx plus b form, so I know that my y-intercept is 4. Looks like my slope here is -2. In other words, -2 over 1. Feel free to write that down, -2 over 1, but that means we're going to go down 2 over 1. Down 2 over 1. You guessed it, down 2 over 1, down 2 over 1. And because it's less than or equal to, we're going to have a solid line, right? And our shading, which again is going to be very light as you can, less than, so we're going to be shading, below. So again, shade, this is not exactly what I would call light shading, but shade as lightly as you can. Now this other one, x is greater than -3. This is a linear equation. It's a very special case of graphing a line. Remember J.Falk? Because this only has an x variable. So J.Falk, so Vux. So this is going to be a vertical line. So what we do is we go over to -3 on the x-axis, and we're going to have a vertical line at x equals -3. And because it's strictly greater than, it's got to be a dashed, broken line. Now, as far as the shading, maybe this is the only little plot twist here, but as far as because I don't know if we've covered this yet in class or whatnot. I probably mentioned it at least once, but I don't know if I mentioned it in the videos yet. So this vertical line, normally you go to shade above or below. Like this greater than symbol means you're supposed to be shading above. But a vertical line is literally the only situation, it's the only kind of line where there is no above or below. Right? There's no above a vertical line, so there's only left or right. So this is the only time, literally the only time, you're going to be allowed to think of the shading as left or right. So what do you think? Do you think a greater than symbol implies that you shade left, or do you think it means shade to the right? Normally greater than means shade above. So what do you think? Do you think greater than means you shade left or right? Well, I'm hoping you're saying to the right. So you're that's no good. Luckily, you guys don't need to use a mouse like I am. So we're shading to the right of the vertical line. And now for your final, again, hopefully you shaded very lightly. Now for your final answer, your graph, you're going to be going with where you shaded twice, which is this area here. So this would be like your final answer. And remember, technically, this stuff and this stuff isn't a part of your final answer, okay? Now this next one, once again, example B here, again, luckily, both of these are ready to go, for my lines because they're both in mx plus b form. This first one, -6, okay, it's a little bit out of bounds, but no big deal. We can manage. And the slope is 3, so up 1, 2, 3 over 1. Remember, the slope is not, well, it is 3, but full rise over run would be up 3 over 1. 3 over 1 is 3. 3 over 1. And it looks like my line is going to be solid. Hey, I thought I clicked on the other color, man. I swear I did. Now I'm gonna just for variance here. You can, you can shade however style. Like some people do this, For my shading, again, I want to shade below because it's a less than we shade below. So some people like to just kind of do stuff like this for their shading. Whatever. So we can call that my shading. And, so now the other one, once again, -4x plus 2. So I already know from the get-go that my b value is 2, and my slope is -4. So -4 over 1. 1, 2, 3, 4 over 1. And it looks like my line is going to be dashed. Oh boy. So there's my good old line, and once again, you can do for the shading. So this is being shaded above because of the greater than. So shading above would be on this side. Oops, it's the dashed line, right? We're shading above the dashed. I went all the way to the solid line there for a second. What am I doing? Such a perfectionist. All right, so now hopefully because of the cross hatching or whatever, you can kind of tell, where your final shading, is supposed to be, all this stuff. So whatever your style is, if you wanted to just do all the shade, kind of color it in. Technically it's shaded everywhere. You're supposed to be literally coloring in all the solutions. And there's solutions everywhere. Nice solutions right on, integer coordinates. But there's also the messy decimal answers. So literally everywhere. Okay? That looks pretty cool. Alright, so unfortunately, we're also throwing this into the mix. Absolute value. But again, we have enough experience here where we're going to be okay. This one, I hope you realize, is going to be a line. A very special line because it only has a y variable going on. So that's like your Hoy-Vux situation with Hoy, H-O-Y, or H0y. So this is going to be a horizontal line at y equals 4. 3, 4. Now is it going to be dashed or solid? That's right, dashed. Whoa, baby. First of all, let's... So a horizontal line, not my greatest horizontal line ever. Yes. Look at these cool tools. I'm going to overshoot it though. Yeah. It's like a seesaw. And we're going to be shading where? It's a less than, so we can totally shade below as lightly as you can. Okay. Again, you can just kind of draw some lines, but ultimately you just want to know where we're shading twice. Now this other one I hope you recognize is going to be a V. And looking ahead, it's going to be what, a dashed V or a solid V? It's going to be a solid V. Now remember how we like to do this. If you can compare this directly to the parent function, and base your graph on, like, is it shifted to the right or left or up or down? Are we flipping the V upside down? Are we vertically stretching it? In other words, changing the slopes of your V. Now with this guy, the only difference to like the original parent function is that we have a -3 right there, which is going to shift the V to the right. So the parent function has a vertex at 0, 0. We're going to shift to the right 3 notches, and that's it. That's it. Okay? Other than that, it's got a slope of like up 1 over 1, and it's going up, like we're not flipping this upside down. The only change from the original parent function was that everything got shifted to the right 3 spaces. So there's my V, and like I said, it's going to be a solid V, like that. And again, it's an inequality, so there's going to be some shading. Are we going to shade above or below? It's a greater than, so we're going to shade above the V. Again, lightly, because it's ultimately going to depend on your final answer, which is where the double shading occurs. So in here, going directly right and directly left on a mouse, or directly up or direct, is really tough. Alright, so there's my final answer. Just the double shaded area, which you want to darken in. Alright. 2 more examples. Okay? 2 more examples. If you want to try these on your own, go for it. You can more than feel free here to pause the video and try these on your own. I'm going to do them in 3, 2, 1. Alright, I'm actually going to do example B first, because I'm going to do example A like the other fancy way with the V, but you'll see that in a second. So this example, once again, I really hope you recognize that both of these are not V's. The second one is a V because it's absolute value deal, but this top one is a line, and you want it to be an mx plus b form, which it already is. So b is +4, slope is down 2 over 1. I feel like we just, what was +4? Oh my god, is this the exact same one maybe? I don't know. I know it looked familiar. Maybe we're shading on the other side, I don't know. But down 2 over 1, down 2 over 1. And is it going to be solid or dashed, peoples? It's got a or equal to line, so it's going to be solid. And I kind of like the crosshatch thing. It's greater than, so we're going to shade above, so some very light shading, or alright. And now the other one is a V, right? And how do I graph that V? When you compare this to the original just plain old parent function, the only thing we're tossing in here is a -4 inside the absolute value, which is going to shift it to the right 4. Remember, if there was something after the fact out here, it would cause it to shift either up or down, depending on if it was a plus or a minus. And if there was a number out here other than just an invisible 1, that could potentially flip it upside down if it was negative, and it would change the slopes. But, I mean, all that's happening here is that we're shifting over to the right 4 notches. The slopes are still up 1 over 1, and we're still going right side up. So, I guess there's already a dot there, so I'm just going to go there. And once again, it's going to be, what, a solid V, or, remember, with these inequalities, it's solid or dashed, remember? And it's going to be a solid V. And as far as the shading goes, it's a less than, so we're going to shade, below. I guess I'll go straight down. I don't know. I don't know if I like that. We'll see how this goes. I don't know, man. Maybe it's kind of pointless because you can kind of see, like, we're going to be shading below this V, so we kind of know that the double shading is going to be all up in here. Like there will be shading below the V all out here and stuff, but I mean, it's pretty obvious to me anyway that like the final shading is, oh, come on. Is all of this. Concentrate. Concentrate. You have no idea how much this is bothering me up here. I'm just going to go for it. Yeah, good enough. Good enough. So that's that one. Now over here, I guess this is going to be our final problem, because the end. So here we go. Now first of all, this one is a line. I really, really, really hope you recognize that this is, in fact, in mx plus b form. It's just that our m value right here is what? It's 1. It's invisible, but our slope, our m, is going to be 1. What's our b value? That's right, it's going to be 0 right there. So again, our slope was 1 or 1 over 1. Ba-bam. Ba-bam. Cha. So graphing this puppy, probably thinking like, Mr. Falk, do we really need all these dots? I mean, no. I'm sure you know the answer is no. We don't need them. And so that's going to be a line. Solid or dashed? It's greater than or equal to, so it's going to be solid. And the shading, I'm going to go like really light gray. The shading is greater than, so we're going to be shading above. Very lightly. Very lightly. Now the other one is a V. Now, if you pause the video and you did this on your own already, you probably did this, if you did it correctly, you probably did it by knowing that this is the same as the original parent graph, except to the left 5 spaces and down 2 spaces. And no flip, no change of slope, from 1 over 1. So you can totally do it that way. Okay? Just like over here, this was a shift to the right 3 only, and this was a shift to the right 4 only. This would have been to the left 5, and then down 2, But what I'm going to do is I'm going to remind you of the other way to graph these V's. Because let's say there was like a 3, directly, not out here, not out here in front of the absolute value, but inside the absolute value, right in front of the x, like a 3 or like a 1/4 or something, directly in front of the x, you pretty much need to do the two separate cases that are going to make your two separate lines that form an x. Remember this? The x method, the two lines method, that, ultimately is going to be a v, because you're going to either go with like the upper half of the x or the lower half of your x, whichever one makes sense according to the situation. So here's what I'm going to just remind you of that method. Remember, this x plus 5 that's in the absolute value, in the first case we have a positive quantity of x plus 5, and in the second case we have a negative quantity of x plus 5. That's it. It's still minus 2, it's still minus 2, it's just a positive quantity of x plus 5 or a negative quantity of x plus 5. This guy, you can just pretty much like drop the parentheses and say it was like x plus 3. So again, please do this very lightly, And ultimately my v is going to be solid. Ultimately, I know my v is going to be solid. Alright, so x plus 3, that's like, well, I guess I can do the whole like, there's my y-intercept of 3, and apparently I have a up 1 over 1, so I can go like up 1 over 1, up 1 over 1, or I can go in the reverse direction to put all these dots. So again, I'm making two lines that cross as an x. Okay? So there's my first line, which again I know is going to be solid. But again, do lightly, especially this, very lightly, very lightly. And the other guy, the negative case, well, remember, this negative distributes, so it's going to be like negative x, and then a negative 5, and then when we end up being able to do minus 5, minus 2, we get a negative 7. So this other one ends up being y equals negative x minus 7. Ooh, okay. Still manageable, because this is minus 5, so 6, 7, and I know that my slope is like negative 1 over 1, but I'm going to be going in the other direction, so like boom, boom is like there. And by the time I get back in bounds, I'm going to be like there. Okay, so boom. Not amazing, but manageable, right? But bam. And I know this is going to be, again, eventually it's going to be a solid V, so why not? Whoa. So how badly did I screw up the not bad. I guess I should have been more down here, but oh well. Whatever. The bottom line is, here's our x. Here's our x. Now this x has to sort of update into a v. So are we going to go with the top half of the v, or the bottom half, or top half of the x to make a v, or the bottom half? Basically, you're deciding on, is your v going to be right side up based on this inequality, or is it going to be upside down? Do we have an upside down v or a right side up v? Now, since there's a positive 1, it's invisible, but this 1 out front here is positive, our v is supposed to be right side up. So we're going to go with the top half of our x for our final v, okay? So again, all this stuff, like this line here, this line, hopefully you drew this very lightly because we're not end up even using it. Now as far as the shading goes, because remember we still need to shade, this was a less than or equal to, so we're going to shade below the v. Well, I guess all this, right? Everywhere below the v, would be everywhere below the V, wouldn't it now? You know? And so, like, remember, the final answer is where we've done double shading. And so apparently that's in here. You know, and if you want, you know, maybe you stopped. Oh man, I will live with it. It's like going back to kindergarten. Now, color between the lines, you know, Mr. Falk. But obviously, you know, if the graph was, if we were to like zoom out on our graph, we're kind of going up all up in here too. But yeah. So I know we went into like fairly deep waters there when we threw absolute value inequalities into the mix. But again, the overall bottom line is you have a system of two inequalities, which involves like either solid or dashed lines or V's, and there's going to be shading, and you're just going to graph both of them on the same plane, and you know, your final answer is where you've done double shading. And again, like if you would have done this the family type way, you know, again, like did this kind of follow up on how we would have shifted left 5? Yep, there it is. Like there's the vertex at shifted left 5 down 2. No change of slope, so it's like up 1 over 1, up 1 over 1, and right side up. Yeah. So however you're going to graph your V's, just remember the basics here about systems of inequalities.